Okay. Please forgive me, but I did not hear which problem I'm looking at.
Oh, 8D on the old test.
8D. 6,
Yeah.
7, 8. A, B, C, D. Very good. So we have limit. Oh, did I start this? Yeah, I did it. I did. So x approaches infinity from x sine 4 pi over x. Okay. So this over infinity, just this piece, approaches 0. But this is the infinity times 0 because sine 0 is 0. So this is a product. So if you remember, we said last time that products are not a big deal. They shouldn't be a big deal because a simple algebraic manipulation should take care of it. So I'll write limit as x approaches infinity. And this is sine 4 pi over x divided by 1 over x. This function is the same with that function because when I divide sine by a fraction, I have to flip the fraction and I get that. However, this serves a big purpose. Why? Because now the numerator is 0 and the denominator is 0. I want that. The reason is L'Hopital's rule. So this is limit as x approaches infinity. When I differentiate 1 over x, I get negative 1 over x squared. When I differentiate sine, I get cosine of 4 pi over x. But now I have to differentiate the inner function, which is 4 pi times 1 over x prime. Four pi times 1 over x prime, which is negative 1 over x squared. And I like this because these two go away. They are the same quantity at the top and the same quantity in the denominator. And now when I plug in infinity, or I say, actually, I don't really plug it in. When I say x approaches infinity, this approaches 0. But cosine 0 is 1, and 1 times 4 pi is 4 pi. You could say that y equals 4 pi is a horizontal asymptote at infinity, for sure. This was a really interesting, it was a nice limit. So this is sorry, forgive me.
No, it's fine. So before, I don't know if I'm wrong, but before we were I would think of as plugging in the limit value, as x approaches a number, we would plug it in, but now it's more you see what the function or part of the function approaches.
Yes, we always did. Yes, we always have to do that because I don't know what I'm facing. No matter what it is. No matter what it is. It's just that I cannot really say that I'm plugging in infinity. But if this were 5, I would have had to say I am plugging in x equals 5. It's just for infinity, I cannot really say that.
Okay.
But I do the same thing no matter what, always, because I need to know the type of indeterminate case, without which I don't know how to continue. Yeah, it's just that I can't say that I plug in infinity. Good, very good question. Next problem. It can be from WebAssign, it can be from anywhere. I don't see everyone finishing up WebAssign anytime soon, so that scares me. Please, with at least 60%. Okay? Next problem, anything else? Anyone? Would you like to choose, or you want me to just solve problems? If you don't want to review, go ahead.
Can we do a Newton's law one?
Yes, any problem, please choose.
Okay, I have e raised to the x squared equals the square root of 5 minus x cubed.
Inside.
Yeah.
Like this.
Yeah.
Great job. Good. So first of all, I have this. In step 2, so this is step 1. In step 2, I have to denote the function. By f of x, or whatever you want, it doesn't matter. In step 3, I have to find an interval. So first I have to make sure that I know that this is defined everywhere, but this is not defined everywhere. 5 minus x cubed has to be greater than or equal to 0. I cannot just plug in numbers without disregarding. So when I want to solve this, I get x to the third less than or equal to 5. And I can take the cube root. I have x less than or equal to the cube root of 5. So I could look at numbers between negative infinity and the cube root of 5, which is a little bit more than 1. My calculator. Yes, I forgot to plug it in, so it's charging. Sorry about that. Okay, so in y equals, please, y equals, I plug in the function second and e, and the power is x squared, and then minus the square root of, and in parentheses, 5 minus, I put parentheses. This calculator doesn't require parentheses, but others do, so I have to be mindful. Not everyone has this particular calculator. And then second and table. And as you see, anything to the right-hand side of the cube root of 5 will be undefined. So I have to stay to the left. So I'm going to put -1, and I'm going to put 0. That's all I need. I'm not going to ask you to determine all possible solutions. I only care about one, any. So I see that this function, first of all, f continuous on the interval -1, 0. Also, f is differentiable on -1, 0. And then by the intermediate value theorem, there must be a solution. And someone confused, I think, the intermediate value theorem on this quiz. I'm so sorry, I'm going from one thing to another. But on this quiz I saw, I think it was on this. Yes, I don't remember it, and it's not important, but I think I saw it in one of your quizzes. You used the intermediate value theorem instead of the mean value theorem. So be careful. The mean value theorem is something else. Okay, where am I? So continuous and differentiable on this, and it changes sign. So f of -1 is positive, and f of 0 is negative. Okay, then by MVT, by mean value theorem, not intermediate value theorem. I'm talking about something else, of course. The intermediate value theorem. By intermediate value theorem, there exists a C in the open interval -1, 0, such that f of C is 0. In step 4, I will create Newton's method, or Newton's function, whatever you want to call it, as x minus. F of x is at the top, and the denominator is f prime. So let's write it. F prime equals e to u prime is e to u times u prime, and then minus 1 over 2, the square root of 5 minus x cubed, times the inner function prime, which is negative 3x squared. I will clean it up just a tiny bit. 2x e to x squared, this is positive now. 3x squared over 2, the square root of 5 minus x cubed. This is a lot of work. I have to be very careful how I plug it in. So careful here with 2x e to x squared and plus 3x squared over 2, the square root of 5 minus x cubed. And now we have to make a decision if we want to start with negative 1 or 0. Can I start with 0? No. Careful. I cannot start with 0. This is 0, this is 0. And this will be 0. I cannot start with 0. I have to start with negative 1. We do not have two choices here. We only have one. So x sub 0 must be negative 1. So let's put the Newton's function in the graphing calculator. Okay, don't erase what you have. So just enter, insert, and you have x minus, put parentheses around the top, all the way outside, and divide in parentheses. Now I have to be careful how I plug that in. 2x, and then e again, to power x squared, and then come down, plus. This is a product, the numerator is a product, so it's okay if I do not put parentheses. I'm always careful with that, but you should put parentheses, but that's okay, it's a product. Now, you have to put parentheses around the denominator here, or you divide by 2 and then further divide by the square root. So, it's up to you. I will put parentheses around the denominator here, to the square root of, and I put parentheses, 5 minus x to the third, close the parenthesis under the square root, close the parenthesis outside for the denominator, and close the last parenthesis for the denominator of this entire fraction. Let me know when you're okay with this, and when I can continue. Do we have this? Anyone? Is anyone working with me on this one?
Yeah.
Okay. So now we go to second and quit. I want to get out of there and go to variables. And then I'll go to, say it again.
I didn't get it all in.
You want me to show the function again?
Yes.
So I have x minus this, and the denominator is 2x, x e to x squared plus 3x squared, careful here, divided by, in parentheses, I put this denominator, this small denominator in parentheses. I also put the what is under the square root in parentheses. And also I have the big parentheses for the entire denominator, which is the first derivative. And after that, I will get out of there with second and quit. Should I still wait?
No, I got it now.
Okay, so get out of there and then go to variables, go to y variables, and function is selected already. I want to choose function y1 because that's where Newton's function is for me, and I have to plug in -1 in it. I have no choice here. And I plug in, and I press enter, and I get the first iteration. I forgot to ask how many decimal digits we want. It doesn't matter. I mean, we can stop. We can stop after. How many?
6.
6. 6 decimals. Fine. So I have negative 0.94428245562. And then I recall with second an entry, but I have to overwrite -1 with second and minus. With the previous answer, make sure you delete anything else. You should only have y1 of, in parentheses, previous answer. And I press enter. And the next answer is x sub 2, which is negative 0.9388108189. Now I don't have to do anything. Second and entry, boom. Second and entry, boom. So I copy x sub 3, negative 0.93876404. And let's see, I don't have to copy the next one because I have 9.3, I have 8.7, I have 6.4. And I stop. So the method converged in 3 steps. Or you can consider 4 if you want to say that this is the first step, that's fine too, but the calculations are 3 steps. It was an interesting problem. Be very careful. It's catchy because if you plug in 0, you're not going to get anywhere. That was one of the problems that Newton's method may have. If we are not careful, the initial value makes f prime 0, and then the method will not converge. Will not give us anything, of course. It's going to be error from the very beginning. Good. Next question.